Let's try another one. Water vapor is a greenhouse gas. This statement is true. There is a single statement of fact and no logical component or linkage to mess it up. But let's dig into the fact part of this statement. Everything gives off energy. We think about the sun giving off energy, but the earth also gives off energy, and even you are giving off energy right now. The hotter the object, the more energy it gives off, and the shorter the wavelengths of that energy. The sun is hot, so it gives off a lot of energy, and it gives it off at short wavelengths. A lot of it is visible light, some of it is ultraviolet, and some of it is infrared. When that energy hits the Earth, some of it bounces off shiny objects like snow and ice and goes back out into space. And some of it goes into heating up the Earth's surface and atmosphere. And you, when you sit outside on a sunny day. But we're not as hot as the sun, so objects on Earth give off less energy and at longer wavelengths. Here's another way of picturing what happens to that energy. First, there's incoming solar radiation passing through the atmosphere. Then it heats up the Earth's surface, and the Earth gives off or emits long wave radiation back to the atmosphere. But here's a new part. What happens to the energy that goes back to the atmosphere? Some of that energy escapes back into space, but some of the energy interacts with some of the gases in the atmosphere, heating them up and causing them to vibrate faster. That energy interacting with the gases is heating up the atmosphere. As the atmosphere heats up, it helps warm up the Earth's surface, both land areas and the ocean. This process is called the greenhouse effect because this is similar to how the sun's energy gets through the glass of a greenhouse and gets trapped in there, making it much warmer than the outside. The atmosphere behaves like that too. Let's talk in a little bit more detail about how the greenhouse effect works. Most of the gas in the atmosphere does not interact with that outgoing infrared radiation. Most of the atmosphere is made up of things like nitrogen, oxygen, and argon, which really don't care about the radiation going in or out. However, some of the outgoing infrared wavelength energy is absorbed by these greenhouse gases. These are water vapor, carbon dioxide, nitrous oxide, methane, and ozone. There are other ones, but these are the main ones. If we look over at our graph now of our incoming visible radiation, you can see that mostly it passes through the atmosphere without interacting too much with the greenhouse gases. And even where there are little bits of effect, there's still an awful lot of energy coming from the sun. When we look at the outgoing radiation, however, we see that the different greenhouse gases are absorbing different parts of those wavelengths. Absorbing, meaning they're capturing the energy and using that to heat up the atmosphere. So a little bit of greenhouse effect is a good thing. If we didn't have any greenhouse gases, the surface of the Earth would be negative 18 degrees Celsius instead of the approximately 15 degrees Celsius that we have now. So the greenhouse effect is responsible for making our planet unfrozen and habitable. But another way we can think about the Earth's atmosphere is that it's like a blanket. How thick and warm the blanket is depends on the amount of greenhouse gases. When greenhouse gas concentrations increase in the atmosphere, temperatures on Earth get warmer. It's like we're adding another thicker, warmer blanket. So, greenhouse gas concentrations have varied in Earth's past, but what we're seeing right now is that human activity is increasing the concentration of the greenhouse gases. And a big way that happens is by burning coal, oil, gas, and biofuels that release carbon dioxide. We can think of this as a chemical equation or a cartoon in which our hydrocarbon and combusts in the presence of oxygen and it produces carbon dioxide, water vapor, and energy. The energy is what we're after. The water doesn't matter a lot in terms of the whole water budget of the Earth, but the carbon dioxide gets up into the atmosphere and it acts to add extra warmth to that blanket of greenhouse gases.